So what we're going to do now, we're going to take a frequency graph and we're going to try and find those values. We're going to try to find, essentially we're going to try to draw a box and whisker plot and find the relevant values. So first we need to figure out what n is. So how many values do we have here? So we have 21 plus that, plus 32, plus 51, plus 45. So n is going to be 201, which means that Q1, or the position of Q1, the position of Q1 is going to be 201 plus 1 over 4, which is equal to 202 divided by 4, which is 50.5. And so what does that tell us? It tells us that, so that's the position of Q1. So we need the 50th number. So this is up to 21, this is up to 28, this is up to 38, this is up to 40, this is up to 60, and we're kind of done, right? So the 50th number is going to be over here, so Q1 is going to be 12. So then the position of the median is going to be 201 plus 1 over 2, which is going to be 2 over 2 over 2, which is going to be 101. So the median, or Q2, is going to be, we need to find 101. So 84 plus 17. Oh, that's right on the edge. But the 101th number is going to be 17. It's going to be 17 because of that, not because of that. I don't know why I kept those numbers the same. That was a mistake. And Q3 is going to be 201 plus 1 times 3 over 4, which is going to be 202 times 3 divided by 4 is going to be 151.5. So it's the 151th position. So we're going to keep on going. We're up to 104, we're up to 135, and then we're up to 160 over here. So 151 is going to be in this, which means that Q3 is going to be 24. And we have our values here. Okay, so let's use them now. So we know that Q1 equals 12, Q2 equals 17, Q3 equals 24. The lowest value was 4 and the highest was 31. So the lowest value was 4, and then Q1 was 12, 17, 24, and then the highest was 31. And that would be our box and whisker plot. And some values, the interquartile range, which is, the box is going to be 24 minus 12, which is going to be, it's actually the same, and the semi-interquartile range is going to be 6, and the range is going to be 27, like that. Next thing, I'm not going to go over it too much. I'm just going to kind of throw it in here at the end of our quartiles. There's something called percentiles. So with quartiles, we divide it up. So when we had quartiles, that we're dividing up the data into 4 chunks. So let's pretend those were evenly spaced. Percentiles is pretty much the same, except instead of dividing it up into 4 chunks, you're going to divide it up into 100 chunks. So if you're on the 51th, the 53rd percentile, I mean, you'd be closer to the average. So in fact, if someone in the 53rd percentile would be a bit higher than the average. There's not really many formulas for that, but the position of the pth percentile It could be written as p times n plus 1 over 100. So the 53rd percentile would be 53 times n plus 1 over 100. That would be the position, and then you'd have to look at the actual data to get the number.